The first thing we do when given any question is draw, using the information we are given, as much of the solution as we can. In this case, we draw our lines CD and AB and we label them up. Here we have a 3D model of our two lines AB and CD in elevation and plan. The model shows an isometric view of the two lines. The question asks us to find the shortest horizontal distance between the two lines. So firstly, we must find the two lines in a view that will show them to be parallel. So to do this, we refer to the principle: if a line is parallel to a line on a plane, it is parallel to that plane. So we bring a line in through A, and this will give us one line on the plane. The line AB is another line on the plane, and next we need to find the line that will be parallel to CD on the same plane. So we draw a line from B parallel to CD, and this will create the plane in elevation. Next we drop this down to plan, where we do the same thing again. We come parallel from CD to B, and where the parallel line in elevation but our level line, we drop it down, and looking out through A, this gives us the plane in plan. We can create the same plane in SolidWorks to show how the principle works. The model shows the plane created in elevation and in plan. Now that we know the line is parallel to the plane we've created, we need to find this plane as an edge view, as this will show us the two lines parallel. From our principal lists, we know that a plane is viewed as an edge when any line on that plane is viewed as a point. So we can rotate this around and look in at the bottom line of our plane until we find it as a point, and in this view we will see both lines to be parallel. To find this view, we looked out along the bottom line of our plane to find it as a point. So now we go back and do the same in our drawing. So in plan, we look out along the bottom line of the plane we created, and we draw an auxiliary view looking in from this, as this will show us the two lines to be parallel. So we draw our XY1 line, and we bring out all our points A, B, C and D. We take our heights from our previous elevation, and we mark in the two lines and label them up. This shows the two lines to be parallel. To find the shortest distance between the lines, we must look in directly at line DC and AB. As the distance we need is the shortest horizontal distance, to do this we will go perpendicular to our XY1 line. Find the shortest distance between the two lines. After we have found them parallel, we draw a plane perpendicular to our x1, y1 plane, and we call it x2, y2. Onto this plane we project our lines CD and AB, using the distance from the x1, y line back. And there are our lines. Now we need to find the shortest horizontal distance. So where the lines cross is the shortest distance between the two planes. So you can see on the model, by putting in a plane, it will cut the model of the lines in the right position. Next, we just highlight this line, and we can rotate the model to see it in the 3D section, not on the plane at the back. The green line represents the shortest horizontal distance between the two lines, and as we rotate the model around, we can see that it's parallel to the ground, and there it is in the view that shows the lines parallel. Now in your drawing, you need to project it back through the views to find it in your plan and elevation. To go perpendicular to our x1, y1 line, we project the line on out and draw a perpendicular x2, y2 line. We project our A, B, C and D points and take our distances. For the purpose of this question, we take a datum line, the purple line, and step our distances off from there back in plan. So once you've that done, you can draw in the lines and label them. Where the two lines cross is the shortest distance between the two lines. We bring this point and project it back through our views to plan and elevation as shown in the model a few seconds ago. Where the blue lines cross the lines AB and CD in plan and elevation, these can be joined to show the shortest horizontal distance between the two lines. The same principles can be applied to any skew lines questions to draw solutions.